All right, let's go on a little journey, shall we? We're going to go deep inside your computer. In this explainer, we'll peel back the curtain to see what exactly happens in that split second between you clicking on something and it magically appearing on your screen. And trust me, it's not magic, it's something way cooler. I mean, think about it. You do this 1,000 times a day. Click, an app opens. Click, a window closes. You don't even think about it. But it's this incredibly complex, beautifully choreographed dance between all the parts inside your machine. So what is actually going on under the hood? Well, it all starts with a simple, universal blueprint. Believe it or not, every single thing your computer does, and I mean everything, from launching a huge program to just wiggling your mouse, it all follows the same powerful 3-step plan. Once you get this, you've basically cracked the code on how every computer works. And this is it. It's called the Input Process Output Cycle, or IPO for short. This is the fundamental secret of all computing. You tell it what to do, that's your input. The computer thinks about it, it crunches the numbers, that's the process. And then boom, it shows you what it did. That's the output. Simple, right? But this little cycle is the engine that drives literally everything. So every journey has to start somewhere. And for your computer, that first step is getting its orders from you. This whole first part is the input stage. It's all about translating your physical actions into a language that the machine can actually understand. The easiest way to think about this is that your mouse and your keyboard are your personal messengers. When you type a letter or you click on an icon, bam, these devices are instantly translating that physical action into a digital signal, and they're carrying your orders directly into the heart of the digital world. Okay, so your messengers have delivered the order. Now what? Well, that command gets sent straight to what we can call the digital workshop. This is where the real work gets done. This is where your simple little click is transformed from a request into a reality, thanks to millions or even billions of calculations every single second. So, inside this workshop, you've got a couple of key players on the team. First up, there's the CPU, the central processing unit. Think of it as the master craftsman, the brain of the whole operation that does all the heavy lifting. Then you have the RAM, or random access memory. This is its active workbench, holding all the tools and materials it needs for the job it's working on right now. And they both work together on a complex workshop floor that connects everything, but more on that in a minute. So after the CPU has worked its magic and processed that command, it is time for the grand reveal. It's time to finally see the result of your initial click. We've arrived at the last stage, output. Now, the most obvious output device is your monitor, of course. It's the showcase, the main stage, where the results of your command are finally displayed. But hey, if you clicked on a song, that sound coming from your speakers, that's output too. It's all just the computer's way of showing you, hey, mission accomplished, I did what you asked. Okay, this next part is super important. We're going to tackle one of the things that confuses people the most, memory versus storage. And let me be clear, they are not the same thing. To make sense of it, let's stick with our workshop analogy. So picture this. RAM is your workbench. It's right there in front of you. It's where you lay out all your tools and all your parts for the project you are working on right this second. It's super fast to just reach out and grab what you need. But, and this is the key, when you turn the power off, that workbench gets completely cleared. It's empty. Now storage, that's the giant warehouse out back. It holds everything, all your programs, your files, your photos. It takes a little longer to go and get something from the warehouse, but it's all kept there safely, even when the power's off. Okay, so the theory is great and all, but let's see how this actually works in practice. We're going to follow a real-world example and trace the complete journey of a single click to see how all these pieces fit together. So let's trace it. Your mouse provides the input. You click the word icon. Your computer's manager, the operating system, sees this and tells the process team to get to work. The CPU, our craftsman, is told to open Word. So it goes to the storage warehouse, grabs the Word program files, and loads the essential parts onto its RAM workbench to start working. And the final output? The Microsoft Word application window pops up on your monitor. See? All components working together in perfect harmony. So now you know the team of components working inside pretty much every computer, and that includes the one you're using right now. And you know what? You don't need to be some hardware expert to find out who's on your team. You can become a tech detective without even opening the case. If you're on a Windows PC, this is so simple. Just press the Windows key and the R key at the same time, and a little box will pop up. In that box, just type msinfo32. That's msinfo32, and hit enter. This command gives you a backstage pass,
pulling up a detailed report on all the components we've just talked about. So once that window is open, you can easily find the stars of the show. Look for the line that says processor. That's your computer's brain, the CPU. Then find installed physical memory. That's your RAM. That tells you exactly how much workbench space your system has to play with. And what about checking on that digital warehouse of yours? Your storage? That's even easier. Just open up your File Explorer, that little folder icon, and click on This PC. You'll see your hard drives or your SSDs listed right there, showing you how much space you have in total and how much you have left. So, you can find your CPU, your RAM, your storage, but a list of parts doesn't make a computer, does it? We're missing the real unsung heroes of the operation, the two crucial components that hold this entire team together and actually give it life. First is the motherboard. Think of it like the central nervous system. It's the giant circuit board that everything plugs into, allowing the CPU to talk to the RAM to talk to the storage, and so on. And then you've got the power supply unit, or PSU. This is the heart. It takes the electricity from your wall and pumps it to every single component, making sure they all have the energy to do their jobs. And this is really the ultimate takeaway. A fast computer isn't just about having the best CPU or the most RAM. It's about how well all those components communicate with each other. Optimal performance comes from stable, seamless teamwork, all enabled by the motherboard and powered by the PSU. So now that you've met the whole team, which player do you think is the real MVP, the most valuable player? Is it the super powerful brain of the CPU? The lightning-fast multitasking RAM? Or maybe it's one of those unsung heroes, like the motherboard that connects everyone? It's definitely something to think about the next time you make that simple, powerful click.